All right, thanks everybody for joining. This is the February 2023 edition of the Houston Job User Group. My name is Jim Bethencourt. I'm the president, and I'm really excited to have Dmitry Chuko here with us tonight. He's going to show us how to get the JVM into Alpine Linux so we can run on Kubernetes all pretty easily, all within what, 5 megabytes, Dmitry? Is that
right? Sometimes.
So, and again, thank you also to our sponsors. Thank you to Improving, my employer. We're also hiring currently. And it's a great place to work. It's been consistently voted as a best place to work by its employees year over year. And I can't say enough good things about it. Also, thank you to JetBrains for donating one year subscription to IntelliJ. Thank you to Hello Tomorrow for offering a one-year subscription to their architectural analysis tool, SonarGraph, and then also thank you to Headway Software for donating a one-year license to their tool, Structure 101 IDE plugin, and thank you to Webcater for supplying for giving a training voucher as well. So. And again, thank you again, Dmitry, so much to you and to BellSoft for giving this great presentation. And take it away, please. Oh, you're on mute.
Yes, I was on mute.
There we go. All right, fantastic. Thanks.
Hello, everyone, once again. We are going to talk about that small, nice containers that lead us for time and space to our Kubernetes deployments, of course. So in this picture, I have a nice red hat as a doctor. But in my, most of my life, I'm just a developer, and luckily I participate in OpenJDK project for more than 10 years now, which is really, it's fun to do it.
That's phenomenal.
Yeah.
Oh, froze there.
BellSoft makes its own build of OpenJDK called glibc. It will be mentioned today. There are, of course, other builds of OpenJDK you're free to choose. And I will also mention new Alpine Linux, maybe a mysterious name, but it's a Linux that we develop. And also other products like Native Image Kit. I won't touch native compilation much today, but it's an interesting technology and we actively participate there as well. And we're among top contributors especially in long-term supported versions of OpenJDK, because support is what we do there. So when we want to write a program and deploy it along with some JDK, what do we do nowadays? Well, we build a container. It's an obvious answer. It's so simple, so convenient, because we have a separate configuration, and inside that container, our applications, all our artifacts can imagine that there's no one else there, there's no other containers, no host things. They just pretend that they are low. Well, if we consider what container is, it's basically just an archive. There's a special format for the file system that contains some files of service files of your operating system, or at least the thing that you call operating system in the container, because it doesn't have a kernel, and your application, of course. And it's all just archived and put somewhere. In the most simple case, which still applies to many scenarios, you can take this archive and transfer it in whatever means do you have to another computer, or use it on your local computer. And use any container management system that's able to run it. And now we use that standard OCI, so-called Docker container image format that allows us to create a container, which is a snapshot of your process or the actual process or a group of processes actually described and backed by this container image. We typically don't use that archives, right? We prefer some registries that actually store that archives or layers extracted from them because it's much easier. We push and pull our container images to and from that registries. In most simple case, it's all located on one computer or within the same network, and it's easy to use. We split or build our container images from different layers, and then we update that layers, we updated images, and we actually run them. Well, it is so simple if we have one instance or if we operate only on a single host, but it, of course, in a generic case, much more complicated. But anyway, this registry, it can be our local Docker registry or whatever container management system do we use. It can be some software as a service, right? It can be Docker Hub. It can be managed registry provided by our cloud vendor. It all works. When we work with some remote registries, it's sometimes convenient, of course, to still have some local snapshot, some proxy to reduce the amount of work with that remote registry. But that's not necessary. Of course, we can use it directly, or still we can use the proxy. Now imagine that we actually have components involved in our deployment located in different networks. So our development work happens in one network. It may be our organization or home network, whatever. It also can be some remote server. We can use some means of remote development like web IDs or just text editors, and keep our code and our built artifacts, built container images in some remote network. Then there's a network where the registry is located, and the target network where our hosts live. So we develop, we prepare container images, we push them to the registry, and then we pull them from that registry to our target hosts. We do it with Kubernetes, or we do it with some other orchestration. Anyway, the topology of how our components and our networks communicate can be different. There's one more interesting case where registry with some base images is a special vendor registry, which is a trusted registry, where we consume specifically prepared stuff. Well, in any case, most of us get used to public and freely or almost freely available services like Docker Hub. Well, there are some limitations. That's why we need more complicated diagrams here, because the thing that used to be free isn't free anymore, or there are some limits on how frequently we can use it. Or we can, of course, buy some resources to have unlimited usage of this thing. And remember that as we cross the boundaries of networks, it typically is not free as well. Because if we operate within same region, within same private network, like in Amazon, it will cost us nothing. Whatever traffic we have there, and it's all fast. But if we operate and use the same cloud provider, but we cross that boundaries, it's not free. And here, as we transfer our container images, obviously having smaller container images would be useful. It just allows us to save time and to save costs. That's the idea, but we'll see how it's being implemented in practice. So first, let's start with the structure of that container images. We base our work on some foundation, on base images that are formally, of course, parent images because they are not empty. And inside such image that contains our application and that base layers, we have operating system components. We have Java runtime, which may be Cherry or JDK. We might have extra operating system packages, or at least some of them are required for that Java runtime, and some of them may be required for our application. Then, of course, Java is great. Java is a big ecosystem where you can find a good library for almost anything. There are libraries that are used by our application. There's a framework typically, and most of applications nowadays use quite sophisticated frameworks like Spring. And by the way, if you build Spring containers using standard means, you will get OpenJDK there inside already, and we'll see how it goes with that option. And on top of that, typically a very tiny tip of that iceberg. That's our application. On the talk delivered by one of VMware engineers, there was a survey about how people do build their containers. And I would suppose that this survey is still valid. So these results are close to current results that we can get by repeating that survey. Still, many people use manual Docker files, or usage of build packs. It grows, but it's not that big. So then we produce container image by any of that option, using any of that options. We start to optimize it. So we can optimize our application first, or we can do it in any case. Because our application is something that we control very well. We may decide to split it, decided that it's too monolithic, let's split it to smaller microservices. In this case, we'll have probably different parts with different dependencies. So we could save and update them independently and save the size of the resulting image by having less dependencies in that parts. We can think about using more effective, more compact frameworks, libraries, or OS packages, because for certain tasks there are multiple choices, and we can rely our selection on such parameters as size, not just performance or other characteristics. In the end, we come to a set of criteria that we would use while we select, for example, our base image with our base operating system. And there's a wide variety of options here. and many criteria that we actually can use for selection. But whatever we choose as a base operating system image, we need to think of how do we install a JDK there? How do we install the Java runtime? It can be installed as a standard package or a package from some third-party repository. And if its package has compatible format, it can be also installed as a binary. But anyway, in the end, we have a combined solution, and it must work. And that's not always the case. Even if we put the system package, sometimes there are some interesting effects that we saw in the
Uh-oh. Yeah, it's one pitfall of virtual presentations. I'll come back.
Yeah, imagine well.
lower
And
the
Dimitri, we
size
lost you
of
for
the
about
image.
30 seconds there.
Okay.
Oh. You actually might try turning off your video.
Yeah, you may want to turn off your video, Dimitri. It might help.
Or just the webcam.
Yeah, just the webcam, yeah.
Oh. Okay. Oh, it's turned on again. So is the sound not too good, or?
Oh, the sound is good.
Yeah, you're back.
Yep.
Okay.
I think it's just a bandwidth issue. So
Yeah, more than likely.
So let's continue here, right?
Yep.
There are out-of-the-box options provided by other out-of-box options provided by JDKs. Like, in fact, then you have full JDK. There are multiple JVMs available. You can use more lightweight client or even minimal JVM. That probably will cost you a lot of performance.
Share your screen. I think we lost it.
Okay, let's reshare it.
your slides.
Yeah. Just the slides, yeah.
Okay, can you see the slide?
Sure can. Yeah, that's much better. Great, thanks.
Perfect.
Love the photo better.
Yeah.
It's much better, but okay.
All right.
This is what I think of when I think of it.
So of course, yeah, we can not just select DM, but sometimes we don't need the entire JDK. We need JRE only. And as I said, J-linked runtime is the corner case of that option. For the OS layer, we can select finally smaller OS images. It can be a different operating system or a different flavor of it with different capabilities. They can be reduced. There are so-called distroless images that aren't actually distroless. They are based on some distro, but they don't have components such as package manager and shell. So it's package manager less. There is now a new modern approach, so-called undistro, which is close to distroless. It's just some distro developed only for containers. So developers don't bother about supporting any builds with kernel, so it can be installed on a bare metal. It only can be used in containers. And for simple programs, if we, for example, compile them as native images, we can really use Scratch as a base. But that's a separate story. In any case, if we have some base image, we can easily expect it using standard or almost standard Docker tools. And if we imagine, if we need some JDK, okay, let's use OpenJDK. What is it? Let's inspect this image. This image exists. It's an image in Docker Hub. And if we look inside it, we can calculate the size across the wire, the compressed image, and the size on disk after it's been installed in our local repository. And for some versions, it used to be more than 500 megabytes. Now it's slightly smaller. But the worst of all, we just said, okay, we need OpenJDK, and we got it. But what did we get? Well, first we spent a lot of time, even on a fast network, so which is not the case for me now. My network is slower right now, so I'll get worse full time. But it's also deprecated. If you read the description of this image, no one really supports it. So it's not being updated. And there is a direct recommendation, please use another image. Well, let's remember the case when we cross network boundaries. And imagine that we transfer something that is based on such bloated image as a base image. We'll have big, long pauses, then we pull this image. And if we need to deploy for many hosts at once, if we update this base image, our service is based on it, well, it will cost us a lot.
That's an interesting number, Nima.
Yeah, it's just a joke. So of course, parameters here are tuned to get the right result. So yeah, but just imagine that you deploy to a number of hosts, and this number is not that large. It's like 1,000 hosts. But at this time in your network, it can be a public cloud or your on-prem data center installation. You transfer a quarter of a terabyte just, to update your program. That sounds scary. There might be unpredictable effects when you do that. So let's try to find good small base image. To do that, we'll look at different alternatives, and there are many of them. Just here are only few. But there's one super special called Alpine Linux, which is extremely small, and at the same time, it has 3 key components that are convenient for development and for production. It's a standard C library, which is different from glibc C library used in many or vast majority of other distributions. It is a package manager, which is, again, maybe new to many of you, but who knows. And it's a shell, which is pretty similar to other shells that we used to, but it may be slightly different. But it's present there. And other images, like distroless, for example, that don't have that components, are still larger than this base Alpine image. And there's a new fashion. Different distros provide slim flavors of the images. So there are full images and slim images. But the slim images are still not that slim. You see they're order of magnitude bigger than Alpine. And even for the different distributions, there are ways to properly bake them as container images with JDK. So that's what we provide when we release our distribution, or when underlying images are updated, or when some CVEs are discovered in different packages. We prepare images that are really small, even for different operating systems. And there's a small image, the smallest among them. There are Alpine images. You see on disk, it's 100 megabytes or even less. I don't remember the latest number, but still around that. And that's a great saving. If we pull that image instead, we just change the line here, we change the name of the image. We don't wait for half of a minute. We just get it instantly. That's the most simple way to get Java on your computer executing something. If you have Docker, of course. You just say, okay, Docker, please run this jar for me. And in a few seconds, it will, if there wasn't any image, it will run the jar. And you'll have only 100 megabytes on your disk spent for that. And doing so, you can easily switch versions of JDK or try JDK JRE. It's so simple. So small containers do help. We save time, we save space. It's so cute, but how do they work? What's inside there? That Alpine Linux, as I said, it is special because it is so small, and it's because it's different. It's lightweight Linux. You already saw that name musl, which is a name of standard C library implementation. So there's a standard that describes what C library must be able to do. And different operating systems, and even implemented differently, and even in the same operating system, there may be an option what a standard C library to use for your programs, what to install. So this C library called musl is targeted to be small, to be standards compliant, but also to be effective in terms of memory, and to be rather performant, not just not to be too simple. And also, it is good to stay secure. Like simple code or important code must be simple. If it can be made simple, then there are no complex design choices. Just make it understandable, make it easily maintainable. And then musl was developed. Developers compared it to other C library implementations. And there are many of them, even for Linux, because if you think about other operating systems like BSD or AIX, they also have their own standard library implementations. So even for Linux, you see here in this table, there are 4 options, but probably there are much more variants. And again, has the same picture as the operating systems. If you compare items like C libraries, there are multiple criteria that you can select for comparison. And important things here is, of course, support for different platforms, compliance to standards, because some libraries may sacrifice the percentage of standards implementation to its size, for example, or drop UTF-8 support, which is not good. So musl is good here. And one of criteria is performance, which is comparable. It can be better or worse than glibc, but it is comparable in all the cases. So this comparison may be slightly outdated or very outdated, but development continues since then, and just new features are added or bugs are fixed, but the concept stays the same. And you see how many platforms are supported by musl C library. And we worked with Java, which also supports many platforms. And it's good that here is a strong intersection between Java platforms that we have in OpenJDK and platforms that are supported by musl C library. I mean, hardware platforms. Well, why do we need C library at all? Because HotSpot JVM is a C and C++ and assembly program. And it uses standard library routines. So it's just regular C++ standard library calls inside JVM itself. Of course, we can also use standard library in our applications, but this is the main point. HotSpot is a major program that we need to run our Java code. And another component in Alpine Linux is called busybox. And busybox is a single binary that combines all different Linux tools we need in our Linux environment. Work on the files, creating something. So all the commands that we are used to are actually performed or backed by a single binary with just different symbolic links. And it makes it smaller. So we only have one binary, so we reuse code there. And there's a special version for musl C library. But busybox is a generic project. There are multiple flavors of it, like it can be used for Android, as you know, if you need shell, or for many other purposes. There's also a dedicated Docker image with busybox only. And again, the code is kept simple, standards compliant, so it's a good key component for your operating system. Of course, when we have specific implementation for tools that we are used to, their behavior or the set of parameters can differ. Well, still it is standards compliant, right? We just can't expect that some non-standard parameters will be supported. So these components and some other components form that tiny Linux, which is tiny as a bare metal installation and it's tiny as a container. Well, let's see what does it mean if we try to build JDK specifically for the different Linux. And we want to do that because it's the smallest base OS that we can get for our containers. And the idea was started to be developed by local engineers. And finally, it became a project Portola. And that project turned into a port, Alpine Linux port, a special port in OpenJDK. And you know, there's a special process of doing big enhancements in OpenJDK called the Java enhancement process, where you describe big change and then you finally deliver this. So BellSoft finally delivered Alpine musl support to OpenJDK, and it happened during JDK 16 release timeframe. So now it's so, it appeared in 16 and 17, but actually we had builds that had this functionality much earlier than JDK 16. So here we talk only about OpenJDK mainline. So now all vendors that wish to release their own binaries, their own builds of OpenJDK for Alpine or other musl-based systems, they use the same source code from OpenJDK.
Yeah, I don't know.
I already mentioned Project Portola, and it was a long way, surprisingly, for such a small Linux support. But finally, it happened, and this is really a non-typical port. So we used to work with ports for certain CPU architectures, but that's.
We lost your screen again. Can you reshare?
Yeah.
Sorry
Yeah.
Thank you.
I heard some sound. Probably it warned me that it really happens now. Okay. Is it better now?
Thank you. Yep. Excellent. Thanks.
Perfect. So it's a non-typical port, known to a different CPU architecture, but it supports to a different C library implementation. And it's mostly not a dedicated chunk of sources, but rather a set of if-defs in OpenJDK code that helps to make a different binary, helps to build it. But for regular users, one of places where we meet native code is JNI. If you really need to call it old way that always works, we just use all that JNI ceremony, but it includes compiling our sources, right? We generate some headers and then we finally compile all the sources, and that tiny native program, that clue, it links to the standard C library. So when we use a different C library, there are two options. We may stay within same C library space for our production and for our development, or we can develop on a machine that contains one C library, but we target systems that are based on a different C library. So it's the same thing as cross-compilation for different CPUs. Like, for example, the laptop I'm presenting from is a trans Ubuntu Linux. It's glibc based. And imagine I need to compile my JNI stuff for Alpine Linux. What would I do? So if it's not Alpine, I will just run a compiler, right? It can happen in a container, or it can happen on my real host, or on remote machine. So it just works. But if I need to cross-compile it, there are means that I used for OpenJDK build and can be used for user binaries builds. You can just get the same cross-tool chain from that is referenced in OpenJDK documentation and build your own binaries on glibc-based systems. That I would say very convenient if you really need the JNI. Or instead, you can take a container with a musl-based operating system and perform that compilation inside the container. That also works.
Wow.
Just remember that if you compile things for one C library and run them on a system that's based on a different C library. You run on Alpine, but you compiled against glibc. There's no glibc on Alpine, and things may break, and vice versa. So that's why you really need that cross compilation. It is very simple. You just change toolchain from standard toolchain to cross toolchain. All other things stay the same. So there are multiple issues that we face during development of this port that regular users may face, but it becomes less and less relevant. So some things stay the same, like LD preload behavior. And you again need to run, for instance, your JNI code, and you need to LD preload for whatever reason you have. It's a native stuff. And it's just being resolved slightly differently. But that's the case for all C libraries. Different implementations are free to do it. Yeah.
Be right there. Walking out there.
And probably you won't face any, PX stuff or debugging. That's not the case. And the last bullet here is more for JDK developers. So debugging process is a bit different with musl. Remember that such a small Linux doesn't have by default some components, but they may be installed easily. And things like off-screen rendering on Linux, many people use that still, require such steps. Or you can imagine Alpine Linux on a normal machine, but that's a rare case. Yeah, and all that outdated points are resolved if in new versions of Alpine and new versions of libraries, and become less and less relevant. So by default, things are okay. As I mentioned, some tools, some standard Linux commands are slightly different on Alpine. That's the example that we met, then developed scripts for that port. But there's no really a problem here. Can be avoided by proper standard usage of really flags described in the standard. Another example is a strict hash bank requirement. Then scripts are executed in Alpine or any other musl environments. So you can see it here. Imagine there's a script run.sh, and it contains only a single line. It's hello world. You expect that it works if you, for instance, run it from Java to exec utility. And it is so on systems like Ubuntu. But it actually won't work on Alpine or other musl-based environments. Because here you are required to have a hash bank saying that this is a shell script and it must be executed by shell. And if we add that line, things just work as normal. Another interesting case is how variables with dots are treated. So they just become empty. But on other systems, there are also issues with such variables because they may be cut or again become empty. Then we set them from the outside. Like here, they're set for Docker to have that variables in the target container environment. But for a long time, Spring, as standard means, for dealing with such things. You can just use underscores and forget about it completely. Another rare case is serviceability agent. If you still use Java 8, that functionality hasn't been backported to, hasn't been implemented in the musl port for Java 8, which is not an official port, but just the port that we have and we use for building musl-based JDKs of version 8. Well, so that's for anyone who used capital F functionality that allows to, inspect applications that are almost dead. Not too many use cases. And this option was removed anyway. So if you use Java 11 and above, it's not there in any case. So finally, Alpine Linux port is an upstream of OpenJDK, and that's so convenient. You can use it with JDK 16 in any distributions that try to build that. But as I mentioned, there are a lot of usages of older JDKs like JDK 11. It's an old JDK, right? Or JDK 8. And their life is not still ended. So multiple vendors provide updates, LTS versions, including BellSoft. And our efforts for all the versions were focused on bringing that functionality as an official port for that versions. That won't happen for JDK 8, but that happened last year for JDK 11. So the builds provided since the build written here by providers who build such binaries, they are built from the same official source in JDK 11U. And there are more hardware platforms like 64-bit ARM. Again, it works there. Or the operating system based on the musl C library can be different. There's a system called OpenWRT used in many routers, for example. And that JDK builds can be used on such systems. It would be great to know if anyone experimented or built some production system based on that. So it's an interesting experience. We ourselves, as a company, use Linux a lot for many systems, for builds. Linux builds are major artifacts being used, and it is so for many OpenJDK vendors. And it's a case that in our company there are many engineers that had great experience building enterprise-grade Linux distributions. And we realized that Alpine Linux is really good, but there are multiple issues with Linux that is not so enterprise. And we realized that we can do it better, that we can develop a musl-based system that uses same package format, which is better suitable in many cases. And of course, we decided to provide support for all that parts of the stack and they can be supported in a single place. Besides of that, we like things to be secure, so we track that vulnerabilities, information, and try to keep it all up to date, keep it all fixed. We know that there are certain performance culprits, and I'll show you how performance of musl can be improved. And besides all that, let's keep all the good sides that we have discovered while working with Alpine Linux. So it's small, it's secure in user space, and we know how to keep kernel secure. And in that systems, there are multiple ways to have a JDK in your system. We, of course, would like to provide the Berica JDK and the Berica native image kit as a default installation option. So it's very convenient. You just install system Java and you get the supported distribution. So Alpine Linux has Stream variant, which is being updated constantly, and also LTS versions that have very long support and update tail. But let's see what are the performance enhancements. As I mentioned, musl library is designed to stay very simple, very portable, very clear. But there are cases when it makes it less performant than much more complicated glibc library. And we knew that one of the cases is related to effective usage of specific hardware instructions for operations, like different string operations. And we embedded effective implementations of such functions into musl. And it's called musl-perf. And it can be installed as a package or can be there in the system by default as your main system library. And we'll see a few screens of different performance results. So what do we try to compare there? We compare a bunch of glibc-based distributions. We compare Alpakita with glibc as one of them. We compare Alpakita musl as one of them. And we compare Alpakita with this enhanced musl-perf. Here you can see that, and there's no musl-perf because during Linux startup, it's not so important to have that optimizations. And Alpakita can be installed as a bare metal installation of operating system. It can be used as a virtual machine image, and also that includes cloud images like Amazon. And that operating system really starts on your hardware or inside your virtualized hardware in virtual machine. And here, start time can be important. Well, it's not always the case, but sometimes it is. And you see that Alpakita starts really fast. It's just an instant startup. There are multiple phases of startup. Like you first have operating system running at all, then you have some processes, then your network is up. And after that, you have a working instance that you communicate to. Another scenarios are related to transferring some data. This is an important scenario, especially in clouds, when we process data, we send, we receive. And it's all related to copying memory and interfering with network and other things. So here, by using musl perf, the performance of such operations can be greatly improved, and it becomes on par with glibc variant of standard library. And you see, Alpine is really great here. Another scenario is working with strings. Then it's one of the most common types of operations existing at all. But the typical length of a string can be different. So here you see that for relatively short strings, using musl perf helps, again, to have well, performance compared to glibc, best glibc implementations, or we can even perform better. So in some cases, like memcmp, Alpine with musl perf just shows the best performance. Yeah, there's a different set of operations on short strings. And if we look at slightly longer strings, again, it's the same situation where musl perf definitely helps. And the difference between glibc implementations is especially high for very long strings. You see, well, if we work with long strings a lot, with very long strings, we definitely need that optimizations.
Large JSON payloads or something.
Sorry?
Large JSON payloads or something comes to mind.
Sorry, JSON?
Large
Yeah.
JSON payloads.
If we process it with if processing of JSON happens, if it includes calling native library or C library functions from your program, it really matters. It's not just Java. So in your system, there may be other services or utilities that work with that strings. You'll see one example on next door within a few next slides. I'll show you. So yeah, you see the difference can be really huge. But you have options here. Alpine provides musl, as I said, it provides glibc, and it provides the supercharged musl. The example that I mentioned is run in Nginx, right? That does string processing, and here musl perf clearly helps Nginx to be more performant. So we just provide we can process more requests per second. So on system, it's a bare metal installation. We just perform more work, but at the same time. And finally, if we discuss Java performance, there are, there's an infinite number of ways how we would compare Java performance in different systems. Here are just all Phoronix benchmarks, and in particular, that's a couple. But we compare not just different C library implementations, but we also compare different memory allocators that we include in Alpine. Sometimes it doesn't matter which allocator do you use when you run your Java program. But surprisingly, for some programs, it makes sense to try a different system allocator. And we include like 4 of them: default one, mimalog, or pimalog, and gmalog. Is probably the most well-known in Java world. So you see, different memory allocators, they do produce different results, and performance can be improved by just changing your memory allocator. And it is very simple. You put some LD preload magic into your command line after you install the appropriate allocator package. It's that simple. And there's, of course, the native allocator benchmarks. Again, we can see different picture by applying different allocator strategy. And it's good that we have all of them. We just can select the right one. As I mentioned, size is still an important characteristic of this operating system. And we provide now our default containers that we really love are called Liberica Runtime. And that containers are still same small as Alpine containers, which we also still update and provide. But they just are based on Alpaca as an operating system layer. They are ready for different tasks, and there are flavors with musl or with glibc. It is still Liberica Lite inside, and musl perf as your C library, or glibc as your C library. There are container images that don't contain the JDK that can be used as a base image in the regular sense. There are also Python images, but anyway, we talk about Java, and you see there are JDK images, and of course there are JRE images of different versions. I mentioned Liberica Lite as an option, and we've made some studies with popular frameworks performance using bare metal installations of Alpaca and Liberica Lite. And they do help to reduce memory consumption. They do help to reduce latency. And there is a special option of producing native image from your application that can show really great results. Not in all cases, but in some scenarios, it can really reduce your memory consumption and reduce the latency. If your microservice doesn't occupy too large heap, if its working set is relatively small, then the collector that's included in that native image performs really good.
So are these graphs for the bytecode-based JVM or the native JV, the native image?
So the best results here are for native image.
Okay.
But there's also a special line for Liberica Lite, because
Got it. Okay.
Here this service is not fully loaded, so it's not on its peak load. And for such cases, Liberica Lite contains functionality that helps the JDK to release unused memory back to operating system. So it reduces footprint for services that are not fully loaded. And here's a small cheat sheet of that can help you to select a proper image for your containers. Let's make a quick walkthrough here. So native images are somehow special. I have different talks about them, but here's not entirely truth written when we think about the size of a resulting image. Binaries produced by native image compilers they can be smaller and significantly smaller than a combination of your traditional Java runtime and your traditional bytecode backtest jars. But there are scenarios when they are still larger, and they have additional, trade-off of being monolithic. So if you update your native image-based container, you probably update it mostly entirely. So it's always in case you have imagine you have a container where your application is splitted into thin jar and libraries. And by the way, when you build container from your Spring application, from your Spring Boot application, it is structured like this. When you only change your business logic without changing your dependencies, you only need to update the thin jar. And if it's in a separate layer, you only need to transfer only that layer between your development environment, your repositories, and your target hosts. So it's a tiny amount of data. And if it's a native image, well, then you need to transfer it all. And if you select it, either you use native image or not, because probably use native image for different performance reasons, instant startup, or to save your footprint, especially if your application is not, again, fully loaded. You select your operating system environment. What package manager is convenient for you? What C library is required for your possibly existing native components? Or if there's no special preference for the C library for native components, or there's no special preference for C library behavior, well, you can choose it based on the size of that C library. In that case, of course, musl is it's much smaller and resulting image will be slimmer. But if you still choose glibc, you have multiple options. You can select any of your, well, at least some traditional operating system parts like Debian or CentOS. Or you can still have Alpine with glibc installed on top of it, or you're going to have Alpaquita flavor with glibc. And it's different because glibc is an official flavor there. It's just installed as a package. And containers based on Alpine that we provide, we just kind of hack it to have glibc in that system and JDK about it.
You lose him? You there, Dmitry?
Yeah. You can use Alpine. You can use Alpaquita.
I think we lost your screen if you're presenting.
Yeah.
I just want to make sure.
And you can use different JDKs that support such slim operating systems. Please try that, compare, pull speed, compare results and compatibility of your images. Please see how they are updated, because it's an important thing, that how you manage the security of your JDK distribution and your underlying base containers when you prepare your deployments or update them. And yeah, give us your feedback. It would be greatly appreciated. And yeah, I'm happy to answer questions.
Okay, sure, yeah. I'll go ahead and monitor the chat, and folks from the audience, feel free to speak up as well.
Share the channel. I'm not sure if I can see the chat. There's only for team members. Yeah.
As well. Either you can unmute yourself and speak up. Otherwise, there may not be a whole lot of other questions.
No. It can be that.
Any particular use cases that you can share where you've seen a positive impact on customers or users?
Yes, like one of our bank usage cases, banking usage cases, they have really positive experience in development because it's just fluent usage of such containers, such base images.
Okay. Nice.
And of course, then you use a light option of Liberica. You have that great reduction in memory consumption for non-active services. And there's a
Nice.
statistics that about 30% of all JVMs are zombies. So
Oh wow! I didn't
they
realize
work,
that.
but they just do nothing. So it's better to don't occupy resources if you if you do nothing.
All right. I guess that's about it. Let me go ahead and for those of you in the chat, let me go ahead and paste the door prize link again. Yeah, are you all able to access the chat in the for those of you on attending virtually?
I don't think so.
Okay, let me go ahead then and share my screen again. And so that is the QR code for the door prizes. So if you want to go ahead and get a snap of that with your picture that with your phone, I'll leave it up for just a minute. And you can use that and you can sign up for chance to win door prizes. And then also next month we have Stephen Nemo from Red Hat who will be presenting on Debezium and how to use Debezium within your Java applications, particularly from Quarkus. But it's certainly a good possibility you can leverage it from your Java application outside of Quarkus as well. He'll be presenting both during the daytime downtown Houston and here in the improving office as well in the evening. That'll be March 29th, if you want to put that date on your calendar. And I will publish that pretty soon if I haven't yet. Actually, I think I already have on Eventbrite. If you go to hjug.org, that event listing will be there. So please check it out. And then in April, we have Srini Pinchikala, who will be talking about the Java flight recorder. I can't remember the exact date on that, but do keep your eyes open for it. It's a pretty powerful tool. If I remember right, it's the Java flight recorder. And so it'll be, we can learn about all the different features that are available. It was made available as open source in JDK 11. So it's free to use now as part of a deployment if you want to deploy that alongside your JVM. So it should be pretty handy, helpful tool to learn more about. That's all that I can think of. Again, make sure that you get you sign up for winning door prizes. A lot of really great tools that vendors want to let us use. So, and again, thank you all for attending. Thank you for being here. And thank you for being part of the user group. And thank you again, Dimitri, for sharing this great information with us.
Thanks a lot.
All righty. Thanks again. Have a safe trip. Enjoy it. Have a good trip in your jug tour. Hope it's an enjoyable one.
Thank you.
All right. Take care.
Bye-bye.
Bye.